Cool. Welcome to the workshop, the RTS workshop. We have had a previous RTS controller workshop, so I decided I wasn't going to just redo what I had done before, but go in a slightly different direction and focus on another aspect that's very popular, that's crucial to RTS games. So I'm going to be focusing on Warcraft 3 style RTS gameplay. So we're going to do some buildings, show you some use of scriptable objects, how to sort of manage all that data and create some UI that is dynamically populated based on the data. So that is really easy to just keep adding new things. We're going to look at resourcing as well, so we'll take these little AI and get them to gather resources and deliver them to the town hall. And yes, we've got our units, which can currently move around, but they cannot harvest, deliver, and they don't have any sort of interaction progress feedback. All right, so let's see what happened on the previous episode of Pigeon RTS. So let me know if the music is a bother, and then I'll turn it off.
It greatly helps with the ambience.
Yeah, exactly. Feel free to jump in at any point, ask questions. You can use the duck to
Hello there.
Get my attention. Okay, cool. So we have click and drag select. You can see how it dynamically adds the AI to the list, to the selection, and we can click off of it to deselect. And then we can also right click in the world, and we can make those little AI. Whoopsie. There we go. And we can make them go over to a new location. Thought about doing like squad mechanics, but we'll see if we got time for that. So in terms of the existing structure of everything, I think I'll just walk you through the project real quick. Okay, so we have a basic AI. I say basic in that it's just an FSM, so finite state machine. Basically, the AI can only be in one state at a time. And the way that this one is structured is to be scriptable objects. So every state that the AI can possibly be in is a script that inherits from AI state object, and that means we can just create new variations of the same state. So we can have an idle that is like lazy, or an idle that is anxious, or an idle that has various parameters attached to it as well. So it makes it very dynamic in how we can then create AIs that use the same states and the same code and the same logic, but react differently based on just tweaking a few parameters here and there. The idle is quite simple. It just waits, and then it also does this little bobbing. So we use do tween over here using a do punch position, and it's just bobbing the mesh up and down to make it look like a little bobbing pigeon. So let's not dive into that too much. The moving is also quite simple. Also just a state inheriting from AI state object here. And then it listens for a destination. So on set target position. Once it gets a target position, then it sets the destination. And if the destination is set, then it's just going to keep monitoring if it manages to actually arrive at the destination. And if it does arrive at the destination, then we switch state back to idle. So the AI behavior over here, the controller, starts off in idle. If you click somewhere in the scene, then the unit move function over here is called, in which case it will switch over to the move, set the new position, and once it gets there, it'll just change state or switch state back to the idle. Okay. So we're not going to dive too much into that. There is a video on that in the event recordings. The last two over there. The dialogue systems one. I think there was another one. Oh, you know what? The original one wasn't actually recorded. Never mind. Okay, but anyways, it's a basic FSM, and if you get to third year dev, then you'll be doing a few of those. But that is not the important part right now. We are going to work on some fancy system architecture. Not too fancy though, because this is rapid prototyping, so you do have to be quick and dirty in some aspects. Oh, and for anyone who's interested in knowing how the drag select works, got that going here in the unit manager. So in the input controller, all the inputs are being funneled through the input controller, and then any other script can just listen to the appropriate event, which makes it really easy to manage new inputs, and also really easy to listen to inputs in pretty much every other script that needs it. So in the input handling, we've got on select performed, on select started, and on select cancelled. So the logic would be you click on a spot on the screen and you drag a box to another spot on the screen, so the started and the cancelled, and during that process the performed will keep triggering a refresh essentially. So when the mouse moves, then it refreshes to calculate what is in that rect that's on the screen. And then the rest is quite simple. We just get the rect by calculating where the mouse position currently is and where it started. And then to actually find out if 3D units in the world are within that rect, we check if the rect contains the world to screen point for that unit. So if that unit exists in the world, we can call camera.world to screen point. That converts its position to a 2D position on the screen, and we basically just check if the rect contains that 2D position. And we just do that for each unit. And if the unit is one that needs to be selected, tell it that it is selected, otherwise tell it that it's unselected. Okay, cool. Back to what I wanted to do. Resources. Resources are going to be important. Yeah, let's make a tree and some ore. So I always start off with the data side of things. So I'm going to create a data folder in my scripts here. And I'm going to make that a scriptable object of resource object. All of my scriptable objects, I usually do the suffix object, just so that when you're reading through the list of all your scripts, it's easy to tell what it is. And then I'm just going to make it scriptable object. Hello. Why is my... There's my scriptable. Wasn't doing the template like I wanted it to. Yeah, so with a scriptable object, I always use the data folder, and then this is going to be resource. And the name is going to be resource underscore, so I can have resource underscore ore and resource underscore wood. Yeah, then I'm not going to populate any fields other than... No, I'm not going to populate any fields now, because we'll figure out what it needs as we go along. So that's another tip, is you don't have to have the answers straight out of the gate. You can figure it out as you go along. Let's do AI states as a subfolder. Just move those in there. And do another one here, resources. And then we can go ahead and create our resource underscore wood and our resource underscore ore. Cool. Then, because this is rapid prototyping, I am going to rip out one of my own trees from one of my other projects. tree. I'm gonna export this one real quick. Why it actually goes and selects literally everything. That is a pain. It's supposed to only select dependencies. Models, pine tree, got the materials, got the prefabs. Okay, cool. Let's re-import that over there. Yeah, as expected, there would be some corrupt things. We can get rid of that. Let's just check if there wasn't. Yeah, that's fine. Okay, and our pine tree. I did set this one to European. Missing model. With the pine trees, yes, that's fine. Okay, I'm gonna have to change the shader because the other one was actually using a different one. Just gonna make this a scarlet lit shader, that's fine. And this is fine. Yes, perfect. Okay, we can delete that stuff thing. Alrighty, okay, so you'll notice we have a resource prefab over here that is just two empties. It's called resource underscore, and then it's got an empty model over there. And if we look at our pine tree, it actually uses that as its root prefab. This is a prefab variant. And then it has the addition of the pine tree model underneath it. And the reason for doing this is so that all resources can be based off of this one root prefab. And if we have 50 resources and suddenly think, oh, we wanted to add a sound source, an audio source, or a particle system or something, it would be all too easy to just go and add that to the root prefab, the base prefab, and not have to go through each of the prefabs individually. Okay, cool. So we've got that tree over there, and it inherits from resource. So let's go and create a new folder in our scripts folder called gameplay. Gameplay is going to have a resource. And we're going to do, let's make it serialized field first. If we need to make it public, we can make it public. But this is going to be a resource object. So that this resource can be identified as a particular resource. And the scriptable objects, their best use is as templated data, essentially. Data that can be referred to or referenced in literally anything, and the data will always be the same. So in wood, we can have like a collection time, that or harvesting time. Let's actually add that to our. No, that is not the right project there. There we go. So resource objects. Let's make a public float for interaction time and call that 3 seconds. So wood might take like 3 seconds to collect, but ore might take like 5 seconds to collect. So that's one parameter that we can change. And If you wanted to, you could have like an easy, medium, or hard difficulty where interaction time is then multiplied by like 1.5 or 10 or whatever. So working with the pure data this way makes it a lot easier than if you were to have those fields on each of the scripts on your objects in prefabs tucked away. So this way we're decoupling the data from the functionality. Okay, so we have our resource script. Let's go and add that to our resource over here. So notice if you're working with a prefab, it'll have these little blue lines, it'll go bold. If you then right click on the name and add a component of there, you'll see you can add it as an override to just Pine Tree, or like I want to do, I want to add it to the root prefab. So now it is part of the resource, which means that it's also part of Pine Tree here. So you can work with prefabs by just seeing what the changes are here and then applying it to the appropriate thing. So this one is going to be wood, and we can right click on that and say apply as override to Pine Tree variant. Okay, and now we've got a Pine Tree that has got a resource script. We can move a few of them around here. And then I'm going to create a new category over here called resources. I'll just reset the transform there. And underneath resources, I'm actually going to create another empty for wood, or actually let's name them what they are, pine trees. Because you may have different trees that have, you know, different resource parameters as well. We'll call that pine trees. Sorry. Okay, go pine trees. Let's see, next thing we want to do is let's implement, oh wait, we'll need something to, we'll need like a collider of sorts to actually enable our pointing and clicking on that. So let's add a capsule collider. Let's see what we need here. Make a height of 4 should be plenty. Set that by 2. It doesn't have to completely encompass the whole tree because in an RTS game you're looking top down, and if you're selecting a tree you are mostly selecting the trunk. I don't know, it's just not natural to select the tip of the tree. That doesn't feel right, and you might want to click just behind it to make units move there. So let's keep the collider nice and small like that. We can probably reduce the radius a little bit as well, or actually just to make it easier to click, let's leave it a bit bigger. That's fine. And once again we can right click on that, and we're going to apply the capsule collider to the pine tree variant. So every resource will need to have its own colliders because every resource is a different shape, size, so that'll work just fine. And I'll also want to collect not from that one but from this one there, my gold deposit. Export that package. That would have been an easier way to do that last time. Okay, and let's see the environment. We've got our gold deposit there, prefabs, gold deposit. Let's see what that looks like. Well, That is far. Okay, there's our ore. Gold ore. Yeah, that's kind of nice nestled between the trees there. So this one, I was working on a mini RTS game, multiplayer thing, and what I thought was interesting with this one, let's just see, no, there's no gizmos. I created all these little transforms around the ore here, so that you can have, you know, multiple people working on the resource at the same time, and they all have dedicated spots. So you can have 25 units mining the same ore at the same time. With that, it'll just be a simple case of having a list of transform, and when a unit goes to collect, then take one of those transforms out of the list of available spots. See what else is on here. Let's remove that. Nav obstacle is fine. Rigid body, we don't need a rigid body. And sphere collider. I'm just wondering if that's the best collider for this shape. Maybe let's go with a capsule, but then turn it. Reduce increase the height, and turn it on the Z-axis. That's what I want. Something like that. Yeah, that should be easy enough to click on then. Okay, then I'm going to make this part of our resource structure and add this whole thing under model. I'm going to copy that component, reset that one, and paste those component values back there. And then this one is going to get the resource ore, and I'm just going to remove that one and move this to the root. I have to copy it. See the other one? Yes, it is on the root. Okay. Just keeping convention, making sure that everything in the project is structured same kind of way, and offset that one slightly. There we go. And make a prefab variant from that. So that's now our resource gold. Okay, looking like a little bit of an environment. And pop that under there. Nice and organized. Okay, so now we want to select our units and right click on something that's interactable, like our tree or some kind of resource, and have the agents walk over there, harvest the resource, and then return it somewhere. So we're doing it like Warcraft 3, where the unit has to bring the resource back to the town hall. So that's another important thing that we're going to need. Let's just do a quick town hall over here. I don't have a fancy model for this one yet. I might go look for one just now. But let's make it... Yes, let's go with a cube. Trusty cube. Just a 2x2 cube. That's our town hall. And that's going to be a building. So I'm actually going to do the same kind of thing as what the resource has and make an empty prefab first. I'm going to just reorganize this. Resources. And move those three into resources. Create another folder for buildings. And make an empty prefab as a root. Drop that underneath there and call this building Town Hall. Make that a prefab variant. And create another empty, which is a category. So let's use the 3 dashes as a category. And drop that under there. If you find that your hierarchy is longer than the height of your hierarchy window, then you've got a problem. And you should definitely start categorizing things a bit better. Same goes for like even all these resources here. If that gets really long, which it can, then consider grouping them into some kind of way, like maybe as regions, or like cardinal directions, or yeah, something. Okay, Town Hall is going to be a building script. So let's create a building. So with the buildings, every building can operate differently. It can have different logic on it. Some buildings might produce weapons or items. Others might be for resources, resource collection or processing. Others might be for research as well. So buildings can be vastly different one to the next. Usually in RTS games, there's quite a finite amount of buildings that actually get used. So it's not far-fetched to think having a script for each type of building would be an appropriate architectural choice. So in this case, I'm going to make my building script a base script, and then I'm going to create another few scripts that will be inheriting from that. So I'm going to make another folder because there are going to be quite a few scripts related to this. So like resource might not need a script for every type of resource because they all get interacted in the same way. If there's something specific that needs to happen, like the tree needs to fall down, we can take care of that with like a Unity event like what Paulo had last night. You just have a Unity event for when the resource gets depleted, and that can then call anything. It could be an animator, it could be another script that does the tree falling over specifically, plays a sound, plays a particle system, and maybe leaves a stump behind, whatever you want. But buildings, they operate a little bit differently. So I'm going to make this an abstract class. And for those who don't know what an abstract class is, it's basically a template class that is not allowed to be put onto a mono behavior on its own. It can't be put onto a game object on its own. It has to be inherited from. But what's nice with an abstract class is that anything you put in here is accessible, or most of it is accessible in child classes as well. So with the building, let's maybe do wandering. I think let's do an interface for that. An interactable. Okay, so I'm going to do an interface over here. And an interface is like the code equivalent of tagging something. It's basically, we're going to tag the code with interactable. And in this way, we can have the building be in iInteractable, and we can have the resources be iInteractable. And interactable in the case of the mechanics of this game would be to right-click on something with selected units. So if you have selected units and you right-click on anything that is iInteractable, it will then execute the interact function in that script. And that can be interpreted in different ways. So on the resource, it would be to harvest, but on the town hall, it would be to open up a menu. Actually. Okay, yeah, so we'll do iInteractable for left click, and we'll do iHarvestable. Harvestable, or let's go with harvestable for now, and we can always rename it at another stage. It's basically the left click versus the right click. Okay, so with both of these, I'm just going to select everything and start typing in interface. Oh, my autocomplete doesn't do the thing I wanted to do. Okay, never mind. It just needs to be an interface called iInteractable. Yeah, that's fine. And then we're going to have a void interact. And that's it for the interface. We're just saying that any script that has this iInteractable tag needs to have an interact function on it as well. And we can do the same thing for this. And this is going to be iHarvestable, and it's going to have the void harvest function. That means my building is going to inherit from iInteractable. And you'll see it goes nice and red because we haven't implemented the missing members, which is the interact. So there's a little light bulb that always shows up here. If you don't know, you can also trigger the action list with control full stop. And then you can say implement missing members. Ryder's really good at telling you what you've done wrong, and then suggesting fixes as well. Okay, then we have our interact over here, and we are going to make this. I wonder if we can make it abstract. Ah, yes, that is good, awesome. So we make this function abstract over here so that we require it in any child class. And we don't actually put the implementation in the parent class here. But that means every building has to have its own version of interact, which might lead to duplicate code. So I'm actually going to make this virtual. Virtual means that I can override it in a child class, but I can also just use the base implementation if I wanted to. So like if I wanted to interact with the building over here, it might be show UI for building info, and yeah, let's just do that for now. And then my resource, I can go and inherit iHarvestable and implement the missing members there, which is to harvest. And then let's say harvest and give it the name. And I'm just going to put that in the building one as well. Yeah, so always put logs in wherever, so that as you're going through and crafting this big system, that when you start interacting with things, you'll be able to at least see things are working, and then you can keep extending from there. If you do too much and then you run it and it doesn't do anything, then you got to start finding out where it went wrong. So now we need a new building script for the town hall. So we make it building underscore town hall. The only time I use an underscore in naming scripts is when it inherits from a parent script like building over here, and you're going to have lots of them. Then it's just nice to categorize. Otherwise, please don't underscore things. That's not conventional. And we're going to inherit this from building. Okay, so with this building, when we click on it, we want the ability to show some UI to make more units. That's what the town hall should do in terms of the functionality for the town hall. But what we were doing was once a resource is collected, then it needs to be delivered to the town hall. So we could have another interface for iDepot, iResource Depot. Though that doesn't really iDepositable, iDeliverable, no. See, it usually ends in able. Okay, I'll just go with Resource Depot. Yeah, and that's going to have the void deposit or depot deposit. That's fine. And it needs to have a parameter. We want to give it the resource. Let's go resource object, and let's give it the amount as well. So int. Resource quantity. Can't spell. There we go. Okay, and building over here is going to inherit from iResource Depot as well. And the point of keeping this as an interface is that I could have a lumber yard, which is also a resource depot, but only for wood, where the town hall can be a resource depot for anything. So there might actually be a bool for this. So return a true or false. In which case we just need to do a bool over there, and you can default false. We can also add something additional to our iResource Depot, which could be can deposit, and if it can deposit, then we deposit. So can deposit will be checked for when we're hunting for a depot, and then deposit can be called when the unit actually arrives there. So now our town hall has now invalidated, so we just need to go and add that one, can deposit, and we can return false here. And we can use this resource object to then filter anything that is applicable. In this case, because it's the town hall, we're actually just going to return true because it doesn't matter what it is. It will be true. It can take anything. Whereas, like I said, a lumberyard might only be able to take wood, in which case you would have like a list of resources or a list of resource objects called like deposit filter. And then you could say return deposit filter dot contains resource object. So basically, if that deposit filter, that list has this scriptable object, this resource object, then it will return true, and if it doesn't, it will return false. So it can or it can't. I'm actually just going to leave that there as an example, because there might be other resources that we can't deposit at a town hall, maybe like a rare gem or something. Let's just make that a filter then. Okay, now we need to tell our units to go to a resource, collect it. So we need to do some kind of detection when we right click. So let's go to our input and follow the float there. So it's action is our right click, I believe. Select is our left click. Okay, and then the on action invoke is called, so we could detect it then on, let's do it on the unit manager, because we're going to need access to this list of selected units. Oh, there we go, on action. Yeah, so we're already listening to the on action event there. So we have a public static unity event on action. It doesn't pass any information along with it. If you're watching Paula's stream last night, he did show how you can, in the brackets here, give it something, and then that unity action will pass along a variable as well. But in this case, we just want to know if it clicks, and then we can use our access to mouse position to then cast array and blah 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 blah. We are already listening to the input controller on action over here. And here we are already casting array. We're using the action mask. So let's go see what action mask had. That is on the unit manager. Okay, action mask is currently everything. We might not want that on everything, but for now, see, we probably only want that to be the floor and resources, and to probably be obscured by any environmental ones, but to be click through on units. So I'm going to add a layer. Resources, units, and let's do environment. Then everything under, well, that's the plane, so let's make that one environment. So that will be part of the raycast then. Then our pine trees are going to be resource. So if we set that to resources, yes, change children, and then we can apply that to that variant. So now they're all the resources layer. Gold, we're also going to do that, resources, yes, change children, apply that override, and I'm just going to quickly apply it to the root prefab as well. So apply it to resource there, and this one as well. Apply it to resources. Okay, and buildings are going to be part of, I suppose we'll need another one for buildings then. Buildings layer, and let's apply that to the root prefab building. Our building needs to have our script on it. We haven't put that on. Building town hall. Okay, now deposit filter, we can now add, we do want ore and we do want wood. Let's apply that to, oh no, definitely not to that, so we can just undo, apply to the variant. Hello. unit manager. We don't need everything. We want to use environment, buildings, units. That is it. No, not units, sorry. Not for the action, that is. Just environment and buildings. Yeah. Okay, so back to the code. If we click on the environment, we want to start checking for any of our interfaces. Well, our interactable interface for action, because that's a left click. So if hit dot try get components, or hit dot collider dot try get components, and we're going to try get the interactable from that. Then we're going to do something with the interactable, else we're going to use it as an opportunity to deselect units. Although if we left click on the building, we should probably deselect the units anyways. Okay, let's keep the deselection in there. Oh wait, hold on action. It's telling them to move. Ah, yes, okay, so on action is our right click. So actually we don't want interactable, we want harvestable. So if we look for harvestable, then we're going to do something with then we're going to harvest. Go to and harvest that resource. Else we are just going to move to that exact point. So unselected units move. Then it's going to go to the point on the map. So let's do another Unity event here. And we're going to pass in the harvestable itself. So unselected units, harvest. Inconsistent accessibility. Make interface public. Yes, make that interface public. Interactable, I suppose, should also be public then. And resource depot. Okay, and then we're going to go and say on selected units harvest dot invoke, and we are going to give it harvestable. So we just broadcast this. The units that are selected will then hear this this event and then react to the harvestable. So go to the harvest, go to the object and then harvest it from there. We actually probably want to do 2 parameters here. I'm just saying because the harvestable being an interface, it's only got access to this. It doesn't have access to the transform or the position or anything like that. So I'm going to pass along harvestable as well as transform, because I need to get to that point. And it's going to be hit dot transform. Okay, so then we're passing 2 pieces of information along there. Yeah, that looks good. Over to our AI behavior, and we can duplicate that listener there. I can never type just unit. It always, my fingers just immediately add a Y at the end of it. It's going to be our harvestable and our, whoops, transform. move these down. Always keep refactoring your scripts as a continuous thing. Just make sure that it reads, the flow reads nicely, that it's logical. And then because we add the listener, let's also remove the listener in the onDisable. Always do this immediately. It's so easy to forget to do that. Yeah, in production projects, found a few where it's add listener in the onEnable and add listener in the onDisable. So what that means is that you start doubling up on listeners, and with something like the input system, you will start getting double inputs on all your listeners. So do be careful of that. Okay, we have unit harvest. Then yeah, we can just copy everything that we've got in unit move here, because we're just checking if we're selected, then we want to switch state, and we want to switch state to move, and then when the move is complete, then we'll want to switch state to the harvest state, which we need to create. So what's really nice with the way I structured this was I added in a Unity event. So if we look over here at switch state, we have Unity action on complete equals null. So because it equals null as default, you don't have to have it when you call the switch state. But if you do, then when the state comes to an end, it will execute that Unity action. That coupled with a lambda expression over here, basically an inline function. So over here, this function over here inside these two curly brackets will only fire at the end of all of that. So later on, like many frames later, then we can run whatever code we want in here. Oh, this onComplete is actually for when the state changes completely. So there we go, current state.disable state. Then we run the onEnable. So we're not actually checking for when that state ends. Position that I want is going to be transform.position. Let's just get it walking over to that location first. Then we'll take it from there. Okay, so this little guy's in the way, and that little dude. There we go. I thought there was another one. Oh, there's only 6. I thought there were 7. No, there are 7. Where's the other one? Oh, it's in the box. There we go. Okay, save that. Let's run that. Okay, so we can select a unit, and we can go to the destination, and we can go to that destination. We need more logs. We need to know if it is actually detecting correctly. So if we do get that, let's add a log over here. Unit manager, and it's going to be harvestable let's say actioned, because that is the naming. And then let's also make it selectable in the debug. So if you do a comma after the text part of the debug, then whatever you put in here, if you click on that debug log, then it will select the game object in the hierarchy for you, so you can see what it hit. Otherwise, we're just going to say unit manager move to point, and that's going to be hit.point. Okay, there we go, move to point, good. And if we click here, still move to point, interesting. Move to point. That was also moved to point. That one's also moved to point. Let's figure out what's going on here. We've got the collider. It's on the resources layer. It's got the resource which has the iHarvestable. And we don't have the resources layer, of course. Resources. Aha, there we go. iHarvestable. Pine tree found and actioned. Perfect. Okay, now we can go and add a new AI state. And I'm gonna duplicate the idle one and then just rename it. Forget to rename anything that is idle there. We're just holding in Control D to select all the same word. And then we can easily just rename it. Yeah, there's that onComplete there. So the onComplete gets fired when the state is disabled or the process has been completed entirely here. Oh, that's when the enumerator is actually finished. Okay. Cool. Okay, so when we harvest, we want to... We just want to harvest for an amount of time. Set the target position. And listen to the onset target. So I guess we can follow the same pattern here then. Yeah, let's do that. Okay, so we've got onset target position. Let's do onset harvestable and give it iHarvestable as well as transform. And then when the unit harvest comes in over there, I suppose it should handle its own movement code because it might need to go to a resourcing socket. So we could just change it directly to a harvest type and then call our onset harvestable and give it iHarvestable like that. Yeah, let's do it that way. Then, because we've added a new state, we'll add one in there. Okay, and that handles multiple states, so that's already fine. Good stuff. Where is my... There it is. So I want to actually copy some of the code from the move state first. Actually, I'm going to copy all the code from the move state, because I want to move and then I want to harvest. Okay, so received destination is false. We're not listening to onset target, but rather on set harvestable. And then that's not a vector 3, that's going to be I harvestable and transform. What did I name it? Literally just transform. Cool. Then the target position is going to be transform.position. See, destination becomes true, which means that this will then set that destination over there. And destination set. It's less than the agent radius. There's arrived destination. Then instead of switching back to our idle state, then we're going to start harvesting the resource. Okay, and for the resource, for harvesting the resource, we're going to wait for a defined amount of time, and then once that time is up, we are given a certain amount of that resource type. Okay, I'm gonna write it in the one big coroutine first, and then I'm going to separate certain logic. Okay, so I'm going to get the time. Wonder if that should be part of I harvestable. So we can harvest there. There's a number of ways that I could do this. I'm just wondering what the best one is. If I call just harvest straight away, it's just going to get the resource immediately. So I need some way to increase progress. Because some resources could be instant harvest as well, like if an object is on the floor, then you pick it up instantly. And others you have to gather over time. I wonder if this can be an I enumerator. Can, okay, with a unity action. Aha. Okay, yes, that makes some sense. Cool, then our harvest is a coroutine that can happen over multiple frames, and when that is done, then it's going to call our onComplete. So then over here, we're going to do yield I harvestable or harvestable. Where's our... Did we save our harvestable? No, we haven't. Okay. There we go. Harvestable. And we can just say the.harvestable is harvestable. And in here we can say yield harvestable, yield return. This is a coroutine, yes it is. Harvestable dot harvest, and then we can say and I need to actually spell that correctly. Ooh. Yeah, okay, so this might be new. This is something I only recently discovered. Third year's alumni, anybody that's more advanced here might not know this. But you can yield return another coroutine and do it like this. So you could say yield return and then the coroutine, and basically it'll just keep waiting here until the coroutine's complete. In this case, I also want to fire off some custom code, so this onComplete here, once that has completed. So basically this is gonna hold up this entire loop until it's done. There is no interrupting it. Unless you call stop coroutine. Okay, so then we go harvestable.harvest. Then the implementation of the time it takes will happen in the resource script. And once we have it here, then what we actually want to do is get the... Then we want to return back to our idle state, I think. Oh no. Then we want to take that resource to our building, town hall. It's not being collected into the ether. Okay, so that means I need to have the resource, and that's going to be resource object. And it's also going to be the amount, the quantity. And then I'm just going to go and add that in as part of my iHarvestable parameters. Okay. So it's going to be a Unity action with two things. A Unity action that passes back a resource object and an int for the quantity. So over here, this one's going to be very confused about who it is and what it's doing. There we go. Now we can get rid of the old one. And here we can just say like yield return new wait for seconds. And the seconds are going to be resource object dot interaction time. And once that's done, then we can just say dot invoke, and we want to give it resource object and the amount, which I suppose we can get from the resource, because the resource would be specific in terms of how much it gives. So let's do an int bundle size. My thinking here is that if it's a shrub, then it's only going to give like 2 sticks, and if it's a giant tree, then it's going to give like 3 logs. So bundle size is part of resource then. Okay, there we go. So now it's going to call that Unity action. It's going to pass along the resource object, and it's going to give the bundle size back. So how many? Let's not call it bundle size. Let's give it. The bundle size sounds better. Because quantity on resource doesn't make too much sense. It's fine. Rename this one bundle size. Okay, and then once we have that, we want to then go back to the town hall. So then our new destination that we want to find is going to be AI resource depot that can take in this one. Bear with me. It will make sense shortly. Yeah, I'm going to do a public AI resource depot. Get nearest resource depot, and it needs to take in a resource object for the filter. And then what we want to do is search, yeah, not even nearest, but rather all of the buildings, and then find the closest one from there. Yeah, okay, so we need a building manager. Definitely need a building manager. Do we have a managers folder? Yes, we do. Let's add a Unity script. Building manager. Get a singleton. Definitely don't want that namespace. And then we're going to do a public void register building, and we've got building, and then have a list of the buildings. And when we register a building, we're going to go and add that to the buildings list. And then we're going to duplicate that and say deregister and remove it. So that's like if a building gets destroyed, and when it spawns, then we can register the building there. Now that we have the building, then we can do a public building find nearest resource depot or resource object, and we can go buildings.reach, and we can say we want the distance, so float distance. Owen, your microphone is unmuted.
Oh shit, sorry.
No worries. Float closest distance equals, let's go mathf.max. So I'm starting at the maximum. Does it need to be brackets? Oh, sorry, not mathf. We've got to go float.max. Max value. There we go. Start at the max value, and there you can see what it is actually there. And then we're going to go work our way down. So go through each building, check the distance. If the distance is closer and it's got the I resource depot, then we're good to go. So first of all, it's if building the try-get component has got the I resource depot out. Then distance. So if closest distance, we want to find the distance to the AI. So actually we need another parameter here. AI behavior, or rather let's just make it transform so anything can check. Target. So if target dot position minus our building dot transform dot position dot square magnitude is less than closest distance, then it becomes our nearest building. So nearest building equals building. We use square magnitude because we don't care what the actual distance is, we just care if it's less than the other ones. And square magnitude is faster because it doesn't do a square root operation. When you're looping over a lot of information, doing a square root operation for every single one of those is very costly. So just good habit is rather use square magnitude where the actual distance doesn't matter, but comparing the distances does. So there we have our nearest building, and then we can simply return nearest building. And that will find our nearest resource depot. All of our buildings just need to register themselves in the on enable dot instance dot register building this, and then we can duplicate that and do on disable and deregister building. So when this building is instantiated, it'll register, and when it's disabled, it will deregister. Now these are on enables inside of the abstract class, which means that they are very easily overridden by accident in the child class. Oh, that's actually not even showing up now, so that's great. So I can make those, the on enable and the on disable, virtual. Public virtual. And then they can be overridden in the child if needed. Okay, back to AI behavior. Okay, so our get nearest resource depot is then going to query building manager dot instance dot find nearest resource depot using our resource object and using our current transform, and that will return can I convert expression type building to iResource depot? Oh, right, okay. So we need to return iResource depot rather. That then gives us the nearest resource depot. We have our utility type function here that we can now use in our harvest state. So in here we can say AI behavior dot get nearest resource depot for that particular type of resource. Oh wait, did we actually check if it had that resource? No, we didn't. So iResource depot is the one that says can deposit. Yes, there we go. So in our building manager, we can say if resource depot dot can deposit, and we give it that object. or let's actually flip that and say if it cannot deposit, then we're just going to continue the loop. So that's going to invalidate that particular building then. So now it's using that filter. Then we're checking the distance. So we're not checking the distance unnecessarily as well. The can deposit's a much quicker check than doing distance checks. And so this should give us an iResource depot that we can actually use and target. Which means now we can say target position equals resource depot. Resource depot doesn't have a transformer position now. Okay, let's out a position then as well. Out vector 3, and this also out target position. Show you what that does in a second. So we're going to add a parameter there to AI behavior. So it's going to out target position here. And in which case our find nearest depot is also going to out target position. Add parameter there as well. And so target position is going to be equal our building dot transform dot position. Otherwise, target position is going to equal vector 30 by default. Okay, so the out parameter is really nice. It's as if we're returning multiple things. So we're returning the iResource depot, but we're also outputting some additional information that we can use, like the target position. Then we pass that back through to our harvest state. And now we can say, now we don't even need to set it because it's going to be set directly right there. So now that we have a target position, we can say received destination equals true, which means that this loop will happen again. It'll say receive destination, it'll set the agent false, it'll set the destination target position and reset that. And then it will keep looking until we reach that one. And once we've reached that destination, then we need to deliver the resource. So, did we get our, yes, we got our resource here. Okay, let's keep this up here then. So we want that's going to equal null to begin with, and the bundle size is going to equal 0. Then in here we can say this dot resource object equals resource object, and this dot bundle size equals bundle size. And then over here we can say if not resource object. So if we don't have a resource object, then we are in the harvesting stage, else we are in the delivering stage. Arrive at destination. Delivering. Okay, and if we are delivering, then we need to tell our resource depot to deposit the resources. So we need to also keep reference to what we collected, or our target resource depot. And then here we can say resource depot dot deposits, and we are depositing the resource and our bundle size. Okay. So on the town hall, we deposit something here, and we can say log depositing resource object name, and let's give it resource quantity. So now we know what we got and how much of it we got. And then let's make this a dictionary so I can show you what a dictionary is as well. Oh, I thought I had Odin in here. Yeah. Didn't bring Odin Inspect into this one.
No cheating, Jared.
You gotta be able to see the dictionary.
I don't know.
Odin is a lifesaver. I'll show you why we do a dictionary rather than having a list. Or you would have to have a list of a custom class type, which we don't want to do. So instead, we're going to do a dictionary of type resource object and int. Just call it bank for now. So we can say bank resource object plus equals resource quantity. And if bank, oops, if not bank dot contains key, then we go bank dot add resource object resource quantity. Dot add, yes. That's not right there. That's better. So that we add the resource object and the amount that we're getting through for the first time. Otherwise, we just find the existing one and then just increase its resource quantity. But now with Odin, so if you look here, serialized field, it's purple. And that means that dictionary is not serializable by Unity. So it doesn't show up in the inspector at all. But Odin Inspector does have it. Is it? It is installed. Come in, Odin Inspector. So now we have the show and inspect over here. And now we can serialize dictionaries in the editor. So our town hall, there we have our deposit filter, and there we have a bank. So you can see here in the bank you can have a key and you can have a value, key value pairs. Yeah, that's fine. Okay, so I think everything is ready to test. Let's run it. My only concern is that it's gonna try get to the middle of the object. A harvestable actioned. Building on enable. We haven't put the building manager in the scene yet. Let's create one here. Building manager and add building manager script there. Perfect. So now we should see the buildings, or the one building register itself here in the start. There we go. We have our town hall. Let's try. So, high harvestable actioned, state disabled idle, and state was immediately completed. So I selected units harvest was invoked. But then, was it listened for? Yes. Unit harvest. Unit harvest. You know what? I haven't actually added that state to the prefab, the unit prefab. So all the AI states need to be in a list over here, and I haven't even created a bloody list, a bloody state for it yet. Harvest. There we go. So now, pop in the harvest one there. Okay, it's promising. Oh my god, it worked. It worked! Delivering is taking a long time though. Where is this dude? Arrived at destination, delivering. Okay, so that's the next step there. It deposited. Oh, well, actually we didn't even check if it did deposit. Let's try that again. Because then we want that action to keep repeating. Okay, go fetch. Yes, fetches it. Does not get deposited. Arrived at destination. Let's just see when that started. Okay, so it actioned, it completed that. It harvested. Set destination back to 0 to 0. And it arrived there, but it never delivered. if we check this guy here, debug it. Let's see. So the resource was wood, and it's got a bundle size of 3. Okay, I need to make that one a serialized reference. So I can actually look at all of this if I make this a serialized reference. Same as that one as well. And then I'm going to make these ones show an inspector and read only. So the show and inspector and the read only, those are also Odin ones. It really helps making them all, the read only ones are for debug variables, so stuff that you don't want to be setting or changing. But then if I look at a harvest one, you can see now we've got resource object there, bundle size, and resource depot and harvestable will also show up. So I just want to see if I can just spot what might be going on. So there we're checking resource depot. We're not populating resource depot. I see. Okay. There, resource depot equals get nearest resource depot. And then it will deposit. And once it's deposited, then we want to start the process over again by going back to the original tree. So what would be the easiest way to do that? Okay, I'm gonna just do this the fast way and then figure out a better way to run this stage. Last I harvestable and last harvestable transform. And then over here, let's say, what's that? Because then, if I want to repeat it, I'm going to make another public function here. Repeat. Honest. And for that, because this checks for selected, I'm going to extract this and just say harvest, because then I can call that one and say last harvestable and last transform, and then just also double check if last harvestable equals null, then let's return false and actually change this to a bool, because we would want to change to a different state than if it was false. And also if last harvestable transform is null, or rather if it's not true, then return false. Otherwise, call that and return true. Great, so now at the end of our harvest, we've arrived at the destination, we have delivered resources. Then we can call AI behavior dot repeat harvest. And maybe let's just say state enabled if it's false right here. Because then that's going to stop that loop from occurring again, which we don't want. Oh, right. If not repeat harvest, then we want AI behavior dot set state dot switch state, and we're going to switch to type of AI state idle. So what's nice with this is we're just giving it a type, not a specific state to change to. And what that's going to do is it's going to check through all of our current states, look for a matching type, and then switch properly to that one. Okay, let's test that. So we should have repeating harvesting going on then. I think this one didn't get the order correct. There we go. Look at them go. They're delivering resources. And they are not repeating? Nope, they're all gathering in the box. Let's see, what is this dude up to?
Well, Jared, it seems like they're having a house party.
Indeed.
The little birds are having a cozy little slumber party.
Yep, exactly that. Last resource is there. Yeah, that's correct. So what happened? What happened? Checks. Yeah, okay, we did set it over there. Which then should have called iHarvest. Wait, let's just follow one. Okay, yes, go harvest the pine tree. Oh no, he's stuck. Maybe the agent is not reset. Off you go. Harvesting, harvest. Back home. State completed. Delivered resources, depositing resources. State completed. Now why didn't it? Oh right, okay, so I can't switch to a state that it's already in. I see. The repeat harvest, we can't harvest because I was going to try switching state to a state that it's already in. Okay, so why don't we just try calling this again? onset harvestable, which means that we don't want state enable to be false. We do want to clear out resource object, and bundle size doesn't matter. Resource depot should also be nulled out. And then this is going to be called again, so we're going to get this dot harvestable is harvestable, we're going to get target position, we're going to get this received destination. Okay, I think that might do the trick. Let's figure it out. Go. Harvest. Deliver. Delivered. Harvest. Ha! It's beautiful. Look at them go.
Work.
There we go.
Work.
Yes.
Work.
That's why I added that sound bite. Oh, we have camera controls, by the way. Yeah, they're all working. And let's see how Town Hall should be getting plenty of resources. Yes, we have ore and we have wood coming in. Ah, very satisfying. So in terms of my checklist of what I wanted to do, we have that, harvest, deliver, and not that. Okay, cool. Not too bad. 2 hours. Implemented much. Cool. Yeah, I'm gonna stop there in terms of implementing anything new. It's working pretty well. Any questions on anything? I know there was a lot of advanced stuff. Sorry about that. And it was pretty fast. Yes.
I have 2 questions.
Yeah.
The first is the delivering to the town hall dependent on their current position? Sometimes my agents have an issue where if many of them go to the same place at the same time, their avoidance thingy kind of freaks out and they just sort of stand still. Is that going to be a problem
so like
here?
you can see how the agents are going into the boxes here. My solution for that was actually going to be, first of all, these objects should actually carve into the nav mesh. So they should have nav mesh obstacles on them. And the second one would be to then sample the nav mesh to look for the closest point. And then you can do that more consistently or constantly the closer you get to the target. So that, because then that would take into account for any obstacles and any other nav agents.
Okay,
So
that's a pretty good
just want to
solution.
get generally close to the object, close enough.
Yeah, I guess it's not that critical that they actually touch the building they're delivering to anyway.
The other solution is like what I was setting up with the mining spots over here, because it's one spot per agent. There's no chance of overlap then.
My second question is not in the scope of what we did today, so sorry about that. But you mentioned at the start something about, can't remember what you called it, but the way I interpreted it was when you move all of your agents to one place, they sort of move nicely. They don't just all try and fight for the same
Squad
spot.
formations, yeah.
Squad formations, that's what it's called. Do you have any insight on how that's usually done, or anywhere I could look to find more resources on how that works?
So there's a number of ways to do it. Like you could just set up preset squad configurations, like in Lord of the Rings Battle for Middle-earth 2. You could adjust how wide the squad goes. So you could have like one single long line, or you could have it like kind of squash in, and then alternating rows would be offset by half a location basically. So you could have a list of vector 3 positions relative to whoever the leader unit is, and then just have units basically fill those gaps.
They like find the closest one to them or whatever.
Yeah, exactly. Some of
Okay.
them, like in Age of Empires, I think it is as well. Yeah, Age of Empires as well, where based on the type of unit it is, they form lines. So you would have your spearmen right in front, and then you would have like your archers right at the back.
That makes sense. Yeah.
Yes. Same with Homeworld. Homeworld does it a lot with their squad leaders and stuff.
Oh, cool.
Yeah, so
Awesome,
it's basically
thank
just you have your target position for the nav agent, and then you just adjust that to account for the squad formation.
Mm-mm.
And
Okay,
same
cool.
thing as the previous question, you can also then use the navmesh dot sample position to find an accurate navmesh position to go to, so that you don't have units trying to get inside of other meshes.
Yeah. Okay, cool. Thank you.
Cool. Any other questions? Thoughts, comments, critiques?